Okay, so first let's talk about data definition. So data definition is the process of making the choices on what concepts are we going to capture, what are the fields that describe those concepts, and how those concepts are perhaps related to one another, right? On what is the structure of the data that we're going to follow, right? And typically the process follows from certain specifications or requirements that we have gathered from having interviewed our clients, right? We've met with them over several weeks and had several meetings with many folks in the organization, and some folks are telling us contradictory things, and some of them are very vague, and they're inconsistent, and it's our responsibility to work that out. Right, so that's one of the more important parts of any project, right? Is agreeing what is it that we're building, right? That's where the projects are most vulnerable, right? Just getting that wrong, those decisions really is going to drive the rest of the project and is going to be a failure. So getting that part right, the specifications and the requirements is very, very important. So data definition is the process of converting that specification into some data structure, some data representation that organizes the data. All right, so the smallest part of capturing an information in a relational database is the table, right? The table is the level of abstraction that we're going to use to collect data. Right, so and a table will be used for identifying or representing some concept. So there'd be a table for students, there'd be a table for our courses, tables that represent our departments, and tables is going to implement some schema that describes the fields inside of the table that will be of a particular type, whether they're integers or strings or floating point or their data dates and whatnot. And each one of those rows in each one of the tables is going to represent a particular instance of a student, a particular instance of a department, a particular instance of a course, right? And with all the fields that go along with representing that particular data point. As mentioned earlier, there's a schema that we're going to be using throughout the semester. We have students, departments, courses, sections, enrollment, no faculty. We're going to follow this nomenclature. Where you see bold, typically that will mean that that's a primary key, meaning a unique identifier that guarantees that a particular record, a particular instance of that will be unique within that table. Okay, so here's an example of what the data might actually look like. Here we have two students, Joe and Dean, with unique identifiers 11 and 22. We have here departments, chemistry and math, with unique identifiers 1, 2, 3, and 2, 3, 4. We'll notice that these students have references, that have values in their major ID field that presumably reference the department unique identifiers of the department. The way we refer to these unique identifiers, we call them primary keys, right? Primary keys, and that guarantee uniqueness. And we have on this side, we have also keys, but they are referring to, right, or their value is needs to be equal to some primary key over here. So we refer to these as foreign keys, right? They are referring to something outside of the table. Okay. Now we could, by convention, say, well, over here I'm going to make these unique, and you just make sure when you insert and you create these records, just make sure that 2, 3, 4, the meaning of this 2, 3, 4 is as referencing this 2, 3, 4, without actually saying that this is a foreign key. We'll just say by convention. Right? By convention, we'll just agree that these two fields, that's the behavior we want to, that's the meaning we give to these two fields. Right? Now, without putting the constraint on it, it could be that we put there some 356 or something like in there, right? And the database won't balk at us, right? It won't complain, right? Because it was a convention. It's something that we agreed on as a social contract between two users or two developers, right? But if we put the constraint and tell the database, hey, database, when I put a value in there, make sure that it actually refers to something that really exists, right? Now that we're making a much more stronger convention here, that we're telling the database, hey, this is actually a foreign key. Yes, we have a contract that this is supposed to be, its value is equal to something else, but I want you to validate that. And the fact that it's a validated value makes it into a foreign key, right? So if we tell the database, hey, that's a foreign key, right, it'll validate that it's indeed valid, has a valid value. Another thing that buys us the fact that something is declared as a foreign key is that, for instance, if I have here sections that are referencing a course, right, and this section over here, we have these courses over here, course 21 and 21 and 32, and we have these two sections that are referring to those two courses. See that? 21 and 32. So these are foreign keys that are referring to these unique identifiers, primary keys. So not only does it validate that these two values actually match, right, that this is actually referring to something that exists, but it also validates that if I ever try to change this 21, say I inadvertently want to modify this value to make it maybe 22, right? It's still unique. It's still unique over here, but the database won't let me. The database won't let me. It says, no. You have a whole bunch of sections over here that are referring to that 21 over there, right? So you can't just go willy-nilly and change that value because you have a whole bunch of folks referring to you. Make sense? So again, by enforcing certain constraints in the database can work with us to make sure that we don't do something foolish, right? That we change the values willy-nilly here and there. Another validation that the database might do is that, if I have here these students referring to these departments, and you have thousands of students referring to the same department, the same math department, what if tomorrow somehow I remove the math department? Okay? Not that we'd want to. No, let's have another example. Where I remove maybe a course, right? Well, what about all those sections that are referring to that course? Right? You have two sections over here. What happens to the course if I remove the course? Is that something allowed? Does that even make sense? Well, it depends what we mean. If we might just not allow it and just tell the database, no, it's a foreign key. That's a foreign key that is referring to a primary key. The default is that it's not allowed. You cannot remove something if somebody is referring to it. Just like a file system doesn't allow you to remove a directory that already has files inside. Yes. Right, the file is working with you, saying you're going to do something foolish, unless you explicitly say that you want to recursively, right, remove it. Same thing here. The database will stop you from doing something foolish, and so because you would have a whole bunch of sections that would be orphans, right? They would be referring to something that doesn't exist anymore. Yes, or you might tell the database that actually that's okay. If you remove one of these things, it makes sense to perhaps do a cascade remove of all the other ones. Right, that if I remove all the courses, it makes sense that to remove all the sections as well. Right, we can make those kinds of rules, right, in the database to cascade certain actions that can cascade all the way through to the rest of the data structure. Yes, if it makes sense. Right, probably we won't allow to remove a department. So if you remove it, so maybe here might make sense. Right, if I remove a course, well, obviously all the sections can't exist, so they should be removed as well. Yes. But what about over here if I remove the math department? What should happen to all the students that are already enrolled in the math department? Or should I also remove all the students that go along with the math department? That makes no sense, right? So in certain cases, we might tell the database to do certain things, and we might tell the data to do something else, right? If we remove a parent, what do we do with the children? Yes? Okay. So it depends. So foreign keys and primary keys allow us to establish these constraints, right? What should happen if certain things happen. Yes? Yes.
So you said if you are putting cascading effects.
Yes.
If you are removing one department and if one student is attached to more than one.
Yes.
Departments.
Yeah.
That
Say again. If what?
If a student is attached with more than one department.
Yes.
And if you are removing one department, let's say.
Yep.
What will happen?
Yeah, so you can specify that nothing happens, that it's okay, or that it will cascade and remove the children, or that it sets it to null, meaning I don't have that reference anymore, so I'll just point it to something null, meaning unknown. I don't know to what.
Like one link of a student.
Well, typically, if you have if what you're saying that you could be enrolled in multiple departments, typically there would be a mapping table in between, one that points to one student, or one student, maybe two departments, right? And there would be two separate records, right? One of them might be removed because that department doesn't exist anymore, or set to null because I no longer know what my minor is, right? I'm definitely getting a major here, and I'm getting a minor in some other departments, but I don't know what that department might be, so it's null. Or it might make sense to remove it, right? Since you're not longer in that department, then that record is removed. And it might make sense, right, to remove the relationship, not the student, but the relationship. Yes? Okay. So again, you can tell the database to do whatever you want it to be, right? It is foreign keys and primary keys that allow us to create these constraints. Okay. Normalization is the mechanism by which we break up the information to avoid having redundancy, right? So the decision on whether to mix and match student features and address features, right? We might have decided to mix them, right? And then if we did that, we might have found out that a lot of the data would be repeated over and over and over. Like for instance, here we are in one big table. We decided to put together things about students and departments and the years that they were, and sections. You know, lots and lots of information in the same table. And what we find is that we have lots and lots of redundancy, right? For this student, this other student, all in the same department. You know, all in different sections and different enrollments. You will notice that there's lots and lots of repeated over and over information, right? So we say that this database is not normalized, right? It's denormalized, right? And that's a bad thing, right? What we try to do is identify these things and say, wait a minute, no, this instead should be captured only once in a separate table, right? And so making those decisions is, we call that normalizing the data, breaking it up into multiple subtables, right, that are somehow related to one another. So what we do is that we collapse this into a separate table, and we say, hey, all these three are actually pointing to that other department that is captured only once. Right? So those are the things that those decisions. We'll talk about normalization a little later. But there's a lot of nuances and a lot of decision making on how to normalize the database. Null values. Null values. So fields could have an actual value, or it could have a null value. And null means just that I don't have a value, right? Meaning I don't know what the value is. It doesn't mean 0. It doesn't mean empty string. It doesn't mean, those are all values, right? Null means somebody just didn't fill out the form. You know, they didn't provide the value, right? And so I don't know what it is. And because I don't know what it is, I can't use it for comparison. I can't compare it to anything else because I don't know what the value is. So oftentimes in our queries, we are comparing some fields against a particular value, whether it's greater than or less than or equal to or between two values or some range. Well, fields that might have null values don't participate in any of those queries because they can't be compared. All right. So oftentimes in our queries, we do our queries and it says, oh, I was expecting many more records. What happened to all these other records that I thought I was going to get? And oftentimes it's because a lot of those fields are null or don't have a value, right? They don't participate. Right? So since they don't participate, I can't say whether it's equal or less than or whatever, right? So they don't participate in the query. So make sure that you understand what null is and how it participates in the query. Keys, as I mentioned earlier, are fields that we can use to identify something as unique. For instance, in this room, first name maybe could be a key, right, that uniquely identifies us. Maybe not. And so, for instance, Jose is definitely unique in this class. I don't know about you. You seem to be from some countries that might have similar names. I'm not sure. And so some of your names might be the same as other folks. So perhaps we might decide that first name is not enough. but the combination of a first name and last name perhaps might make you unique within this room. So those fields that we might decide that we might choose to determine whether a particular data set or data point is unique within the collection of data points are referred to as keys. Okay. Now certain keys, you can combine any number of combinations: first name, last name, middle initial, social security number. Now within this room, perhaps the first name is enough to make us unique. I don't know, anybody you know that has your same first name here? So maybe, right? Perhaps first name and last name might make us unique, right? And we might do a sampling and we'd realize that maybe it's not. So we have to add maybe a middle initial, or we might add a couple of things. Eventually, we will see, we'll come to a point where adding additional fields don't make us any more unique. Okay? So we call any combination of fields that make us unique, we call it a super key, right? And now a super key that has some fields that don't make you any more unique, we call them superfluous fields. You know, we might have the super key might have fields that are irrelevant. I don't really need them to make me any more unique. Okay, so a super key that doesn't have any superfluous keys, right? We call it just a key, right? We just call it the key, right? It might be a combination of fields, all right? So it might be that for instance, a social security number is unique enough here in the United States that it's a key for everybody, right? Well, at least anybody who pays taxes is a unique identifier, right, for all of us. Yes. Well, super key is any combination of keys, right? So you want to know whether you might have other keys in there that you don't really need, right? So they're all super keys. Everything is a super key. You just want the minimum set of fields that I need to actually be unique, right? So that would be a key. We haven't talked about primary keys yet. Primary key is just a key that you're going to use as part of a relationship, right? So they're all keys, right? Primary keys, foreign keys, and whatnot, right? But we add the nomenclature primary key is that first is unique, right? And then we're adding the constraint that is going to participate in a relationship, right? Meaning some other field is going to be referring to it, okay? And there are certain rules that we want to impose. Like for instance, if somebody is referencing you, right, the primary key, meaning some foreign key is referencing them primary key, you can't just willingly remove this record anymore, right? Or you can't just change it anymore, okay? So that's what enforces those constraints: primary key, foreign key, okay? And that has its own name. It's called referential integrity, right? You have these references, right, and imposes certain restrictions. You can't remove this without removing that. You can't just change it, right? So those additional constraints are referred to as referential integrity, and we'll talk about that in a minute. All right. So selecting keys. So selecting keys. Typically, selecting keys should be based on some logical understanding of the fields. Okay? It should not be based on the actual values of the fields, right? So, for instance, here I was using the first name as a way to decide whether the first name is a key or not. Okay, so I could have mistakenly chosen the first name as a primary key, just because in our room all our first names are unique. Yes. So that would by inspection, we might conclude that the first name is a very good key, because I don't have any examples where the rule of uniqueness is broken. Yes? But if I think about it a little further, I'd say, wait a minute. It was unique probably because we had a very small sample. All right, but if I increase the sample, I'll be very easily will find examples where that doesn't hold true. So my original choice of the first name was flawed, right? To use just the first name as the primary key, as a unique identifier. Yes. So what the point is that the choice of your key shouldn't be based on a sampling of data. Okay, just because you look at the sampling of the data and you look that it's always unique. Oh, look at that, it doesn't repeat. It must be a key. So it should never be based on the sampling, but it should be based on the logical understanding of what that field means. All right? So you understand that first names are definitely not a guarantee of uniqueness. Okay, so so you come to the conclusion that I understand what first names are, and I know by definition they cannot be unique. Make sense? Right, so your key should always be your choice of keys should be based on the logical understanding and the meaning of what that field is. Right? Oftentimes we're lazy and we say, forget it. I can't think of something that makes you unique. Let's artificially choose a key. And that's where social security numbers come in, right? And student IDs come in. Right? I can't think of anything that makes us unique. So I'll just think of something arbitrarily random. Yes? That I can then guarantee that that's unique. Yeah, we're not unique. I don't know, maybe your thumbprint or your retina. So also keys, the selection of the keys also impose certain constraints, right? We can choose that a certain combination of fields make the record unique, okay? And that would impose certain restrictions of the type of data that we could insert. For instance, if somebody chooses that the combination of fields professor combined with the year that it was offered, that I choose that to be my key, and that combination needs to be unique, notice that imposes certain restrictions on what I can insert. It could impose certain business rules, right? Impose certain business restrictions. Like, for instance, a professor teaches at most one section a year. Maybe that was written in the specification, right? That a teacher is only allowed to teach one section once a year. I don't know who would ever do that. But nevertheless, the combination of fields, professor, comma, year offer, certainly imposes that restriction. You see that? So oftentimes, business rules that you might find in a specification are implemented as a combination of keys. Right? So here's another one. A course can have at most one section per year. Right? Again, the combination of course ID with year offered. So since this has to be unique, right? And so this particular year, this course can only be offered only once, right? Because otherwise it would break the. I can't insert another record that has the same course ID with the same year offered. I can't, right? Because this is a key. It has to be unique. Another one here, a professor teaches at most one section of a given course per year, right? The combination of courses, professor, and year offer. So oftentimes you'll find these kind of specifications in in the requirements, and you need to think of, well, how could I impose that rule, right, by selecting my keys appropriately. So here's just some examples on some values that implement some of these rules. Duplicate record. So out of the box, the database doesn't impose any of these uniqueness rules, right? It doesn't impose. For instance, it would be perfectly fine that you insert two records that are identical to one another, right? They have exactly the same value. The database won't complain. The problem is that now the database has no way of distinguishing one record from another record. Right? So for instance, if you ask to remove a record that has these particular values, it says, well, I actually found 3 rows that have those same exact values. I'll remove all of them, right? Because it has no way to distinguish one from another. So yeah, out of the box, the database won't impose any of this. It is our responsibility to impose some of these restrictions by, for instance, declaring certain fields to be primary keys. Right? So primary keys, as I mentioned earlier, it imposes certain restrictions. One of them is that the field, that particular field, or combination of fields, has to be unique. Right? So that's one of them. That's for the first restriction. These restrictions, we call them constraints, which is the same thing, right? another fancy word. Yeah, so it imposes the constraint that it has to be unique. But not only is that the only constraints, it also imposes the constraint that, hey, you're going to have a whole bunch of other fields referring to you, right? And once that happens, I'm not at liberty to modify the primary key if somebody's referring to me, right? It's like a pointer, right? In C++, right? It's referencing something, right? And you can't let it go. So primary keys, ideally should be intuitive, meaning it has some kind of meaning. Oftentimes does not. Ideally you can decide on a natural key. Maybe an email perhaps might be a natural key, right? That uniquely identifies you. Yes. But if you can't think of one, or you can't guarantee the uniqueness, certainly we can choose an artificial key. Artificial key meaning it has no analogous representation in the real world, like a social security number. Right? It has no analogous representation of anything other than a piece of card that you're given to pay taxes at the end of the year. Then you have foreign keys that are other fields that are meant to refer to primary keys, fields that have been declared to be primary keys, right? And so so this imposes certain constraints about a field that has been declared to be a foreign key, meaning that its value, by definition, needs to be taken from a valid existing primary key, right? So if I create a student that is enrolled in a particular department, well, that department better exist. It makes no sense that I enroll a student in a department that doesn't exist, right? That makes no sense. So the primary key tells me that that department does exist, and I am enrolling this particular student in that department. Right? So once I create that relationship, there's additional constraints that apply. I no longer can, for instance, remove that record because somebody's referencing it, just like I can't remove a directory that has files inside of it, right? So those constraints are now valid. I cannot remove it. I can't change it. Okay, and if I try to remove it, I could perhaps write rules that would cascade those deletes to all the children that are referring to that parent. So foreign keys, for instance, we have some examples in our schema. We have major ID, department ID, course ID, student IDs. They're all referring to different records in other tables. Like major ID in student refers to the department records. So we're going to be using this nomenclature throughout the semester. Why is this like this? We're going to be using this nomenclature of there we go, where we'll have the table name, right, typically capitalized with underscores. We'll have the primary key. It will be bold, italic, and underlined. Okay, whereas a foreign key will just be bold and italic. All right. So that's a nomenclature. You'll see it in the quizzes. You'll see it in the exams. You'll see it in some homeworks. We'll be using this nomenclature to describe a table and all the fields. Notice that we don't have certain things here. We're not saying whether things are integers or strings or whatnot. If we need to, we'll add that additional, right? We'll say what types of these are. All right. Also, notice here other things that are not mentioned here is that this major ID doesn't say, this foreign key doesn't say who's it referring to. Okay. In particular, this major ID is referring to the department down below. Right. To make that clear, oftentimes we'll make this field have exactly the same name as a primary key that it's referring to. Okay. Then it'll be clear, right? You'll see that this is a primary key over there, and that this one has the same exact spelling and name of that primary key. It's a foreign key. Then, by induction, you would know that that's a foreign key that is referring to a department over there. Make sense? Right. Anyway, so here's a nomenclature that we'll be using throughout. In particular, notice the enrollment table has a primary key here, EID. But notice it has two foreign keys, right? It's referring to a student and it's referring to a section ID, right? This is oftentimes referred to as an association table, right? That it's associating two records, saying that, hey, that record over there, that student over there, it's related to that section over there, right? So they're pointing to two different records. Keys and foreign keys, as I mentioned earlier, they establish a relationship between two records. It's also, the relationship is bidirectional, right? You can always identify the two records that are related to one another in your queries by saying that this field in the foreign key is somehow equal to the primary key of some other record in some other table, right? And that's bidirectional. I can give you one and I can get the other. I can navigate from one table to the other in both directions. Referential integrity, as I mentioned earlier, that the database enforces certain things, that it doesn't disallow us, it stops us from removing certain things, from changing certain things, right? And we call that referential integrity, right? To stop us from breaking the data or inserting bad data in there. So for instance here, if you have students enroll in the math department, and you have these two students referencing this particular math department, what would happen if we would remove this department, and what would happen to these records? Should we completely just disallow that and stop it? Or if I change this to 22, should that cascade and change this also to 22? Right? Or if I remove this record, should also the student record should be removed? What should happen? Right? We can impose those constraints by using Cascade Actions. Cascade Actions allow us to tell the database what exactly we want to happen. Should we just disallow it? Right? Should we cascade the action to the records that are related? Should we if you cascade the delete, sometimes it might make sense, right? Sometimes it might not make sense, right? If you remove a department, should you also remove the students? Probably not. If I leave Facebook, should all my posts be removed as well? Probably. From my point of view, probably from Facebook's point of view, no. They want to keep all the content. But from my point of view, my understanding is that all my content would go with me. Right? If I'm no longer there, everything would be removed, but obviously not. So Cascade Actions allow you to establish what should happen with related records. So some of the constraints. Some of the simplest constraints is that we say that a particular field needs to be a date, or needs to be an integer, or needs to be a string, right? So those are some of the simple constraints. But some other constraints might be that some fields are required, right? Meaning I will not accept a record where a particular field is null, right? So no, it's very similar, very common that you're filling a form, right? And certain fields are required, and it won't let you submit the form unless you provide a particular field, right? So those are kinds of constraints we could put there, null constraints, right? Not null constraints. That they're unique, that they're referencing something else, and then the database can impose these constraints on the database. To create a table, create one of these data sets, we use one of the SQL or SQL commands, create table. So SQL is a pseudo English language based language that was the intent was to lower the bar of entry for folks to start interacting with databases. Right? That was the original intent. Today it's kind of silly, that we have these select statements like this. Certainly the technology has moved on and has made it many different ways of have better interactions with databases. But nevertheless, SQL is still with us and still be with us for quite a while. But nevertheless, the original intent was to make it easier for folks to easily interact with English-like conversations with the database. Eventually, this will get very good, and we'll be able to speak, using natural language parsing and just describe our problem and to Alexa, and it'll create a query for us and the tables and everything for us. Eventually, it'll parse just the specifications, and it'll create the entire application without us writing a single line of code. Oh well, we'll all be out without a job. So create table. allows us to create tables. We have a cascade actions, such as we can know what to tell the database to happen with records that are related to one another through foreign keys and primary keys. That if you delete or you update, what you want to happen. Should I cascade that? Should I set it to null because the record doesn't exist anymore? If you remove something, the other record, should I also be removed? Should I set it to some value, or just don't do anything? Or checks, you can also validate certain things that a particular value should be positive or should be within a particular range. You can check this and validate, make sure that the database can validate your operations and whether it's going to reject or allow a particular update to the database. So here's an example of creating a department table, creating the department ID as an integer that it's required. It cannot be null. We're saying the department names is a string of 10 characters long. It's also required, and we're declaring the department ID as a primary key, right? So it's unique, and it's going to participate in a relationship. So somebody's going to be referring to the department ID field from some other foreign key, like the student table, for instance, right? We have a student IDs. We have a student names. That's a varchar. Department here is going to be used as a foreign key. Right, notice that down below here we're declaring the department as a foreign key that is referencing some other table at a particular field, the department ID. And down below we have determined that if the department goes, we go with it. Right? If the department goes, then we are going to cascade the delete to these students. Right? Update as well. If the department ID changes from 20 to 21 or 22. My department foreign key is also going to change, right? So that I'm pointing to the correct department, even if it changes. Also, we are validating that that our graduation year is after 1863. That's when the university was established. So I can't graduate before the university was established. So some validation. Also, the student ID needs to be positive. So a couple more. Here's a course. Creating the course ID has a title of our chart. Notice we have a comment and describing what this field is all about. Also has a description, has a department, meaning is a foreign key. So the primary key is a course ID, but it has a foreign key that refers to the department, saying that this department field is referencing the department ID. Okay? All right.